Okay, let's talk about tabular integration. This is integration by parts in a quick way. Let's see how do we do it. So when we have a function which looks like u dot v, and when we integrate it, u dot v dx, assume that u and v both are the functions of x, that equals u as it is integral of v dx minus integral of u prime, that is the first derivative of u, times integral of v dx. Okay, so let's see an example for which we usually use this formula. So integral of x cube times sine x dx. I want you to pause the video and try doing this problem using this formula which we just saw. Okay, I assume you pause the video and try the example written down. So let's use a quicker way to do it, and that's tabular integration. So I'm gonna make a table which is supposedly okay. I'm gonna make a table. Yeah, I made a table. So what the idea behind this is that we, on one side of the table, we take the derivatives of the function which will eventually go to 0. Derivatives of function eventually to 0. So which of these two functions derivative is gonna go to 0? And we know that is this one. Okay, so let's write that function here, and the other function, that is sine of x. So the idea is here in this tab, in this column of the table, we integrate, and in this side we differentiate. So let's start doing it until this term goes to 0. So this is 3x squared, this is 6x, this is 6, and this is 0. Oh, I have an extra row now. Okay, now let's integrate this side. That's gonna be minus cosine of x. That's gonna be again minus sine x. This is gonna be cosine x, and this is going to be sine x again. Okay then, this is not difficult. Now let's see what are we going to do. So what we are going to do is take this to this to this. I think so you can see where this is going. This and this, this and this. Okay, and now we will assign them signs alternatively. So the idea is to, let's write this down, how we are gonna use this table. So the idea will be this equals plus x cube minus cosine x, this is plus x cube times minus cosine x, minus 3x square times minus sine x. Then the next term will be plus 6x times cosine x, and the last term here will be minus 6 times sine x. Let's rewrite this quickly. Minus x cube cosine x plus 3x square sine x plus 6x cosine x minus 6 sine x. And I believe this is the answer you are going to get for your integral. Okay then, this was the case when one of the function here, the derivative of this function eventually went to 0, as you can see. What if we have a function where this does not happen? So for example, if we have an integral of e to the x times sine x dx, we can see that the derivatives of this function is not going to go to 0, the derivatives of this function is not going to go to 0. So how should we apply this tabular integration over here? So I'm gonna make a table again. That's the idea, like always. Okay, here's the table. Okay, is this gonna be enough? Probably yes. Okay, the idea is the same as before. Here is gonna be derivatives of one function and integrals of the other. So this is our u and this is our v. If you know the rule LIATE, we start from here and go there and select our u. So let's see what's our u going to be. So as we can see, our u is gonna be here as sine of x. Yes, our u is gonna be sine of x. So sine x e to the x. So derivative of sine of x cosine x. Integral is e to the x. This is minus sine x. This is e to the x. We stop here. And why do we stop here? The idea behind this is we stop where the function which is repetitive comes back to its own. The question might be arise that what about this one then? So the idea here will be we come back to the original function of one of the two functions either by differentiating it again or integrating it again. So we came from here to here, which was the same. We came from here to here and it's the same. There's just different signs. Okay, the idea is pretty much the same but a little bit different. Okay, so here we'll make the arrows as usual. Okay, just do plus minus. Now this is the important part. In this one we have this with us, and what is this purple arrow telling us? This purple arrow here is used for integral. So let's evaluate this as it was. So this is equal to plus sine x times e to the x minus cosine x e to the x, and this becomes a plus then. So plus minus sine x, integral, this is what the integral is for, times e to the x. I'm going to rewrite this as a single line. Integral e to the x times sine x dx equals sine x times ex minus cosine x times ex minus integral sine x times e to the x dx. There's going to be dx over here. Okay, so now the idea here will be this will go on the other side. Okay, so let's do that. I think you have probably already seen what's going on here. So it's integral e to the x times sine x dx plus integral e to the x times sine x dx is equal to sine x e raised to x minus cosine x e to the x. I'm not drawing these brackets here, but those are usually considered as important. Okay, so I'll just erase some of the part. What do we don't want? We don't want this. Don't want it. Okay, so now it's clear. So what is this? This is just 2 times integral e to the x times sine x dx. Therefore, integral e to the x sine x dx is equal to sine x, I'll do that, e to the x minus cosine x times e to the x, which can be simplified further as e to the x by 2 sine x minus cosine x. Whoa, this was not difficult at all. This was pretty straightforward. And this is our final answer. This method will work in most of the cases where you have such kind of things. But remember, if you have functions which one of the two functions which is something like maybe sine of 3x, and when you're asked to differentiate this, when if my f of x equals, then d by dx of f of x will be cosine of 3x times 3. Do not forget this 3. And the same case, if you have the same function again and I'm integrating it, it will be minus cosine x by minus cosine 3x divided by 3. These terms come from the chain rule and they apply when you use the tabular integration. This is just easier and a quickly visual trick which you can do to evaluate integrals for maybe competitive examinations, or maybe some schools may allow you to use this method for your exams. Thank you very much. This was my second video and I'll keep on posting more videos soon. Bye bye.